Hey everybody, Dr. Nelson here. This is a video on how to determine velocity. Alright, so what exactly is velocity? I'm sure it's a term you've heard before, okay? But right here is the definition. So velocity, also called speed, is found by taking change in distance over change in time. Alright, so if you'd box in this equation, alright, so V stands for velocity, alright, and that's going to be the change in distance over the change in time. So delta S is talking about the change in distance and delta T talks about the change of time. Change of time. Alright, so here's an example. It says you start a trip at 2 p.m. Okay, and you drive until 4 p.m. You drive a total of 115 miles. Alright, so let's determine the velocity. Alright, so again, the velocity of speed is found by, this time we're going to use y and x. So the change in y over change in x. Okay, and this is just like finding the slope of a line going through two points. So we know the amount of change in the distance is going to be 115 take away 0. So that's 115. And the amount of change in time going from 4 o'clock to 2 o'clock is 2. So when I do 115 divided by 2, I get an average velocity of 57.5 miles per hour. Alright, so that's just a real basic example of how to determine the velocity. So now we're going to talk about something called instantaneous speed. Okay, and I'm down here now. In order to determine the instantaneous speed, you need to calculate the slope of the line at a given point. Please underline slope of a line at a given point. Okay? And for the past few weeks, you've been learning how to figure out the derivative, which is exactly that, right? Finding the slope at a certain point. So if you turn the page, let's take a look at an example here. All right? So the position of a particle is given by the equation. Okay, S equals t cubed minus 6t squared plus 9t, where t is measured in seconds, okay, and S is measured in meters. Okay, so the first thing we're going to do is we're going to find the velocity at time t. All right, now the velocity is the derivative of the position function since there is a rate of change. So let's write that down. The velocity is the derivative of the position function since there is a rate of change. Alright, so let's figure out the derivative of our function up here. Alright, so I'm going to use the power rule here. So this is going to be 3t squared and then minus 18t, excuse me, minus 12t, and then plus 9. Alright, so here's the derivative we're going to need to use to figure out the velocity. Alright, so now what we can do is we can now use the derivative to calculate the velocity after a certain amount of time. Alright, so for example, what is the velocity after 2 seconds, then after 4 seconds? Okay, so all we're going to do is we're going to substitute this 2 in for every t and get the number, and then substitute the 4 in for every t and get that number. Alright, so what we're going to say is the velocity at 2 seconds is going to equal 3 times 2 squared minus 12 times 2 plus 9. Alright, and when I simplify this, this is going to be 4, and 4 times 3 is 12. So 12 minus 24 plus 9. 12 take away 24 is negative 12, plus 9 is negative 3. So it's going to be negative 3, but meters per second is going to equal the velocity. All right. Now let's do the same thing except after 4 seconds. All right. So I'm going to write it as v is the 4, and that's going to equal 3 4 squared minus 12 times 4 plus 9. All right. And let's simplify this. So 4 squared is 16, and 16 times 3 is 48, and that's going to be 48. And then minus 12 times 4, that's another 48. So 48 minus 48 plus 9. And these are going to cancel out, right? So our answer is going to be 9 meters per second. And there it is. All right, let's turn the page. So the last part of this problem is, when is the particle at rest? All right. Now the particle is at rest when the velocity equals 0. Let's write that down. So the particle is at rest when the velocity equals 0. All right. So if we go back up here, remember we figured out that right here this is the velocity. All right. So what I'm going to do is I'm going to have that equal 0 on the next page. So it's going to be 0 is going to equal 3t squared minus 12t plus 9. Okay. Now the way you solve this is we're going to need to factor out a 3. All right. So when I factor out a 3, it's going to be 3 times t squared minus 4t plus 3. And again, this equals 0. All right. So it's 3 times this. So I can now factor this trinomial. So I'm going to use reverse FOIL, right? So what times what gives me t squared? Definitely a t and a t. And then what times what gives me 3, but adds up to -4. So we're going to go with -3, right, and -1. And that's going to equal 0. And now what you do is you take each factor, and you have each factor equal 0. So it's going to be t minus 3 equals 0. And also t minus 1 equals 0. All right, now I'm going to solve for t. So I'm going to add 3 to both sides, right? Add 3. So t is going to equal 3. And then t is going to equal, I'm going to add 1 both sides, right? Add 1, and add 1. All right, so our answer is the particle is going to be at rest after 1 second and after 3 seconds. So the particle is going to be at rest after 1 and 3 seconds. And there's the answer. All right, so now that you've learned how to use the derivative to determine the velocity, I'm going to pause the video, and there's 2 problems I want you to try. And then when you're done, I'll hit play, and you can see how you did. All right, good luck. All right, welcome back. Let's say you did with this first problem, okay? So it says find the instantaneous velocity for the expression of s in miles and the value of t in hours. All right, so here we have s equals 4t squared minus 3t, and they want to know the velocity at t equals 2. All right, so we need to first find the derivative of 4t squared minus 3t. Okay, so to find the derivative, that's going to equal, let's see, 8t minus 3. All right, and now we need to substitute a 2 in for the 3. So that's going to be 8 times 2, take away 3. And 8 times 2 is 16. And 16 take away 3 gives us 13. And that's going to be 13 miles per hour. And there's the velocity. All right, let's see how you did with the second problem. It says, suppose the position equation for a moving object is given by s to t equals 3t squared plus 2t plus 5, where s is measured in meters and t is measured in seconds. Find the velocity of the object when t equals 2. All right, so step number 1, just like all the other problems, we need to find the derivative of 3t squared plus 2t plus 5. All right, so that's going to give us, when we do that, that's going to be 6t plus 2. And the question is, find the velocity of the object when t equals 2. So I'm going to use a different color here. And I'm going to substitute a 2 in for the t. So it's going to be 6 times 2 plus 2. And now 6 times 2 gives us 12. And 12 plus 2 gives us 14. All right. So the velocity at t equals 2 is going to be 14, but it's going to be meters per second. And there's the answer. All right, I hope this video has helped you better understand what velocity is and how derivatives are used to figure out the velocity.